Welcome to Scoli Sleep Stories. Before we begin, take a moment to get comfortable. Let the day soften around you and settle in for a calm documentary made for curious minds. If these stories help you rest, learn, or simply enjoy a quieter part of the day, please consider liking this episode and subscribing to the channel. Now, when you are ready, let us begin. Chapter 1. The Moon Above the First Humans. Long before there were written words, long before cities rose beside rivers, and long before towers, temples, observatories, or books, the moon was already there. It moved quietly above Earth, crossing the dark sky with a pale and steady presence. It shone over open grasslands, where tall stems bent in the night breeze. It shone over forest edges, where leaves held silver along their rims. It shone over shorelines, where waves folded and unfolded beneath its light. It shone near cave mouths, over stone, dust, animal tracks, and still water. The moon is Earth's only natural satellite. A satellite is something that travels around a larger body in space. Today we know that the moon circles Earth, and that Earth and moon move together around the sun. But for the first humans, there were no written explanations. There was only the sight itself, a bright companion in the night, changing slowly, returning again and again. Every person who has ever lived beneath an open sky has lived with the moon. It was there for the earliest families gathered around low fires. It was there for hunters moving across pale ground. It was there for people listening to the sounds of night, watching the horizon, and learning the habits of animals, weather, water, and stars. The moon belonged to no single valley or people. It rose above many lands, and it was seen by many eyes. We cannot know exactly what prehistoric people believed about the moon. Their thoughts were not written on clay or papyrus. Their stories, if they told them, passed through voices and memory, and most have vanished into time. But we can gently imagine what they may have noticed. They would have noticed that the moon did not always look the same. Some nights there was no moon to be seen, or only the faintest sense of its absence in a dark sky. This is what we now call the new moon, when the moon is near the sun in the sky and its bright side is turned mostly away from us. To people watching without instruments, it would usually have been hidden in the brightness of day, or lost in the evening glow. Then, after a little time, a thin, curved sliver appeared low in the sky after sunset. This is called a crescent, a narrow arc of light, delicate as a shell edge or a pale reed. Night after night, that crescent grew wider. The moon became a half-lit disk, what we call a quarter moon. The name can sound a little surprising, because from Earth it looks half bright and half dark. It is called a quarter, because the moon has traveled about 1/4 of the way through its cycle of phases. The bright part continued to grow. The moon became rounder and fuller, until at last the full moon rose, wide and luminous, its whole near face lit by sunlight. Under a full moon the world could seem gently remade. Stones had edges again. Paths could be followed. Water held a trembling reflection. Grass, sand, and snow, in colder places, could brighten with a soft glow. Then the moon began to wane, slowly growing smaller in light. It passed again through a half-lit shape, the last quarter, and then became a thinning crescent before disappearing into new moon once more. This changing shape is called a phase. A phase is simply the part of the moon's sunlit half that we can see from Earth. The moon does not make its own light. It shines because it reflects sunlight, just as still water may reflect the sky. As the moon travels around Earth, we see different amounts of its bright side. To early humans, the reason may not have been known, but the pattern itself was clear enough to watch. The moon changed, and yet it returned. That quiet combination, change and return, made it one of the most memorable things in the sky. The sun rose every day, bright and warm. The stars were many, scattered in patterns that slowly shifted with the seasons. But the moon was large, near-looking, and easy to follow. It had a rhythm a person could learn with patience. A child might notice the thin crescent, and later see it grow. An elder might remember many cycles. A small group moving through a landscape might recognize that nights of fuller moon gave more light than nights near the new moon. In those brighter times, people may have traveled more easily after sunset. They may have searched for food, watched animal paths, gathered together, or continued simple tasks in the coolness of evening. Moonlight was not like daylight. It did not reveal everything. It softened the world rather than sharpening it. A full moon could lay pale light over a plain, but shadows remained deep beneath trees and stones. It was enough light to guide, to suggest, to make familiar ground visible in another way. For people living close to the land, such differences mattered. A dark night and a bright night were not the same. The moon's presence could change how far one could see, how safely one might walk, and how easily a trail or shoreline could be followed. It could shape the feeling of a gathering, the timing of movement, and the quiet work of watching and waiting. Across long ages, humans learned by noticing. They noticed when certain animals moved. They noticed when plants flowered or fruits ripened. They noticed where the sun rose in different seasons. They noticed the stars, the winds, the cold, and the rains. Among all these patterns, the moon offered one of the clearest. It is possible that some prehistoric people marked its changes. Archaeologists have found ancient bones, stones, and other objects with lines or notches carved into them. Some of these, such as the Ashango bone from Central Africa, have been discussed as possible counting tools, and sometimes as possible records of lunar cycles. Other Paleolithic objects have also been interpreted in similar ways. But here it is best to speak softly and carefully. These interpretations are debated. A row of marks may be a count, a decoration, a memory aid, or something else entirely. Without written explanation from the people who made them, we cannot be certain. Still, the idea is understandable. The moon's rhythm invites counting, a mark for a night, a mark for a return, a mark for the growing or fading light. Such things are easy to imagine, even if they cannot always be proved. Later prehistoric monuments in some parts of the world also seem to show careful attention to the sky. Certain stone circles, earthworks, and standing stones may include alignments with the rising or setting of the sun, stars, or moon. Some sites have possible lunar alignments, including directions connected with where the moon rises or sets at particular times in its long cycle. Yet these too must be handled with care. Stones can point in many directions, and people may have built with meanings we no longer fully understand. Some alignments are strong and convincing, others are uncertain. What remains clear is that human beings in many places looked upward with patience. They watched the heavens closely enough to place meaning in the horizon. Imagine then a night before writing. The fire has burned low. Its last red light glows among ashes. Beyond it, the land opens into darkness, but not complete darkness. The moon has risen. It rests above the far ridge, large near the horizon, pale and calm. A few clouds pass nearby, thin enough to glow at their edges. The ground is silvered. A pool of water holds a second moon, wavering softly when the wind touches it. No one there knows the modern words: satellite, orbit, phase, reflection. No one has measured the distance between Earth and Moon. No one has named the Maria, the dark plains that later observers would imagine as seas. No one has drawn a map of craters or mountains. All of that belongs to later chapters in the human story. But the seeing is already there. A face turns upward. Another follows. Someone remembers that the moon was thinner before. Someone else may know that, after it grows full, it will slowly fade. Perhaps they do not speak of it in the way we would. Perhaps they sing of it, gesture toward it, or simply carry its pattern quietly in memory. The moon asked for no explanation in order to be noticed. It gave light. It changed shape. It vanished and returned. It joined the world of practical things, such as walking, gathering, and watching, and also the world of wonder, where a bright disk in the sky could feel both familiar and far away. Over thousands upon thousands of years, generations came and went beneath that same soft light. People crossed plains, followed rivers, lived near glaciers, deserts, forests, and seas. Languages changed, tools changed, shelters changed, but above them, the moon continued its slow cycle. A thin crescent after sunset, a half-lit moon in a quiet sky, a full moon whitening the ground, a fading crescent before dawn. Again and again, the pattern returned, and from such noticing the first steps toward counting could begin. Not counting in the way of later calendars, with named months and written tables, but counting as memory. This night, then the next, the moon growing, the moon rounding, the moon thinning, the moon gone, the moon reborn in light. In time, human beings would learn to measure that rhythm more carefully. They would connect it with months, seasons, ceremonies, journeys, and records. They would make calendars, adjust them, refine them, and write them down. But before all of that, there was the simple act of looking up. The moon above the first humans was not yet a charted world. It was a companion of the night, bright enough to guide a path, gentle enough to invite attention, and regular enough to become one of humanity's earliest teachers of time. Chapter 2: Moon Cycles and Early Timekeeping. In the quiet after sunset, when the warmth of the day had begun to leave the ground, the first thin crescent of the moon could appear low in the sky. It was not bright like the full moon. It did not fill the fields with silver light. It was only a slender curve, a pale mark above the horizon, visible for a little while before it followed the sun down into the dusk. Yet to people watching carefully, that small crescent meant something. It was a return. It was the beginning of another familiar pattern. Night after night, the moon changed. Its phase, the changing shape of its bright part as seen from Earth, grew from a narrow crescent into a half-lit disk, then into a round full moon, and then slowly diminished again. The bright shape thinned, became a crescent once more, and finally disappeared into the sun's glare near the time of the new moon. After a short absence, the young crescent returned to the evening sky. This gentle cycle offered one of nature's clearest ways of counting time. Long before clocks, and long before printed calendars, people could look upward and see that time was not only a matter of passing daylight, it had a rhythm in the night as well. The moon did not need to be measured with instruments to be useful. Its changes were large enough for the human eye, slow enough to remember, and regular enough to trust. A village might notice the crescent returning after sunset. A family might count the nights from one bright full moon to the next. Travelers, farmers, herders, and priests could all look at the same sky and recognize a shared pattern. The moon became a kind of quiet clock, not ticking, not sounding, but changing its shape in a steady way. The time from one new moon to the next is called a synodic month. The word is specialized, but the idea is simple. It means one full cycle of lunar phases: new moon, crescent, half moon, full moon, waning moon, and back to new moon again. This cycle lasts about 29.53 days, a little more than 29.5 days. Because the number is not a neat whole number, early timekeeping required patience. Some months might be counted as 29 days, others as 30. The moon did not fit perfectly into a tidy human system. Instead, human systems learned to follow the moon's own pace. A lunar calendar is a calendar based mainly on moon cycles. In such a calendar, each month begins according to the moon, often near the new moon or with the first visible crescent. This way of marking time has been used in many parts of the world, though not always in the same way. Some communities placed great importance on the first sighting of the young crescent. Others used calculation, tradition, or a combination of these. Imagine again that village at evening. The sky is clear near the western horizon. Children, elders, and workers returning from the fields look up together. A slim crescent hangs in the fading blue. Someone notes its appearance. A new month has begun. There is something restful in this kind of timekeeping. It asks people to observe. It rewards waiting. It invites the eye to return again and again to the same portion of sky. Yet the moon's month does not match the solar year exactly. A solar year is tied to the seasons: spring, summer, autumn, and winter. These seasons depend on daylight, temperature, rainfall, and local climate. Agriculture in particular has always depended strongly on these solar and earthly conditions. Seeds need the right warmth, the right moisture, the right soil, and the right season. The moon could help people organize time, rituals, festivals, and monthly activities, but planting and harvest also required close attention to weather, daylight, rivers, and the land itself. If a calendar follows only the moon, 12 lunar months add up to about 354 days. That is roughly 11 days shorter than the solar year. At first, the difference may seem small. 11 days can pass quietly, but after several years those missing days gather. A month once associated with early spring may begin to move backward into winter. A festival once held near harvest may slowly drift into another season. This is what is meant when we say that a purely lunar calendar drifts through the seasons. The moon keeps its own faithful rhythm, but that rhythm does not perfectly match the sun's year. Many societies found ways to bring the moon and sun into conversation. A lunisolar calendar uses moon months, but adjusts them to stay aligned with the solar year. The months still follow the moon, yet the calendar also pays attention to the seasons. To correct the difference between 12 lunar months and the solar year, an extra month is added from time to time. This added month is called an intercalary month. It is simply an extra month placed into the calendar when needed, so that seasonal festivals, agricultural markers, and civil life do not drift too far from the proper time of year. The idea is gentle and practical. The moon gives the month, the sun gives the year. Human beings watching both learn how to weave them together. Across the world, different cultures created different patterns. Some calendars were lunar, some were lunisolar, some were mainly solar, some included ritual cycles that did not match the moon exactly. There was no single path, no one first calendar that can be named with certainty for all humanity. Timekeeping grew in many places, from many needs under many skies. Still, the moon was especially helpful because its changes were so visible. A thin crescent after sunset might mark a beginning. A first quarter moon, half bright and half dark, might show that the month was unfolding. A full moon, rising round and pale as the sun went down, might bring a night bright enough for travel, gathering, ceremony, or simply a longer evening outdoors. Then the waning moon, rising later and later, showed that the month was moving toward its close. In this way, the moon made time visible. It did not divide time into tiny pieces. It did not hurry anyone. It marked larger, softer intervals, nights, months, returns. Its pattern suited memory and community. People could say perhaps that something happened 3 nights after the crescent, or near the full moon, or before the moon disappeared. Such phrases joined the sky to ordinary life. In fields, people watched more than the moon. They watched the color of leaves, the swelling of grain, the arrival of rains, the behavior of animals, the height of rivers, and the path of the sun along the horizon. Yet the moon remained part of the larger pattern. It gave shape to gatherings, offerings, markets, stories, and festivals. It helped communities remember when to come together. The return of the crescent after sunset became in many places a quiet sign of renewal. Month after month, the same graceful sequence unfolded. Darkness near the new moon, a young crescent, a growing light, the full round face, a slow fading, then darkness again, and another return. For early timekeepers, this was not abstract mathematics, it was a lived rhythm. It was the sky above the roof, the field, the riverbank, the path between villages. It was the pale light on still water, the silver edge of a cloud, the calm brightness on a hillside after dusk. And as people learned to count the moon's cycle, they also learned to record, compare, and predict. In some places, these observations remained in memory and custom. In others, they were eventually written down. So, the story of the moon as a natural clock leads onward gently toward the first great written records of the sky. Across the river plains of Mesopotamia, between the Tigris and the Euphrates, watchers looked for the first crescent in the evening light. Scribes pressed signs into soft clay. Temples, calendars, and careful observations began to hold the moon's rhythm in written form. Chapter 3. The Moon in Ancient Mesopotamia. In the wide, open lands between 2 great rivers, the moon rose over fields, canals, and cities of sun-dried brick. This land was Mesopotamia, a name that means between rivers. The rivers were the Tigris and the Euphrates, flowing through a broad plain where early cities grew, where farmers watched the seasons, and where scribes learned to press signs into soft clay. At evening, when the heat of the day softened and shadows lengthened along mud-brick walls, people looked toward the western sky for the first slim curve of the moon. A crescent is a thin, curved sliver of light. In Mesopotamia, that first visible crescent often marked the beginning of a new month. The moon had disappeared for a short time near the sun's brightness, and then returned, delicate and pale, just after sunset. Its return was not sudden or loud. It was a quiet sign in the sky, a silver mark above the flat horizon. Month after month, the same pattern unfolded. The crescent widened, the half-lit moon appeared, the full moon rose bright and round, casting gentle light across temple steps and riverbanks. Then it waned, growing thinner night by night, until it vanished again into the brightness near the sun. To watch the moon carefully was to notice time taking shape. Mesopotamia produced some of the world's earliest written astronomical records. Astronomy is the study of objects in the sky, the moon, the sun, the planets, and the stars. In Mesopotamia, this study was closely joined with religion and omen reading. An omen was a sign believed to carry meaning. The people who watched the sky did not separate science and sacred meaning in the same way many people do today. For them, careful observation, mathematics, and divine messages could belong to the same world. The moon itself was honored as a deity, a god. In Sumerian tradition, the moon god was called Nana. In Akkadian, a later language of Mesopotamia, he was often called Sin or Suan. Nana was associated with the bright crescent, with the measured flow of months, and with the quiet authority of the night sky. Important centers of moon worship included the city of in southern Mesopotamia, and later Haran, farther to the north. At temple buildings rose above the plain, their steps and terraces catching the changing light. By day they stood warm beneath the sun. By night they could glow softly beneath the moon. One can imagine a courtyard after sunset, the air cooling, the last colors fading from the sky, and the first crescent appearing above distant fields. For the people who lived there, this was not only a beautiful sight, it was also a moment of order, a sign that a new month had begun. The records of Mesopotamian sky watchers were written on clay tablets. Clay was common in the river plains, and when softened with water it could be shaped and marked. A trained writer, called a scribe, used a reed stylus to press wedge-shaped marks into the clay. This writing is called cuneiform, from a word meaning wedge-shaped. Each small impression was simple, but together the marks could preserve names, numbers, offerings, observations, and long lists of events. Some tablets recorded the phases of the moon. A phase is the changing shape of the bright part of the moon as seen from Earth. Other tablets recorded eclipses, planetary movements, and omens connected with the sky. A lunar eclipse happens when Earth's shadow falls across the moon. The moon may grow dim or take on a coppery tone, but the event is simply a matter of shadow and alignment. Mesopotamian observers noted such events with care. Over many generations, these records became a deep store of memory. A single observer sees only one lifetime of moonrises. A tablet can carry observations beyond that lifetime. A temple archive can gather many tablets, and many tablets can reveal patterns that no one person could easily hold alone. Babylonian astronomers, working within the wider Mesopotamian tradition, developed sophisticated mathematical ways to describe and predict the moon's motions. Their methods were not modern astronomy, but they were careful, systematic, and powerful. They knew that the moon did not move through the sky in a perfectly simple way. Its timing varied, its path shifted. Yet with patient records and number patterns, they learned to anticipate many lunar events. Among the cycles they recognized was an eclipse cycle, later known as the Saros. This cycle is about 18 years and 11 days long. After such a period, the sun, earth, and moon return to nearly the same arrangement, so eclipses of a similar kind can occur. This did not mean that every eclipse could be predicted for every place with modern precision. Lunar eclipses, which can be seen over a wide region of Earth when the moon is above the horizon, were easier to anticipate than solar eclipses at a particular local place. A solar eclipse happens when the moon passes between Earth and the sun, and its shadow falls on only a narrower path. Still, the achievement was remarkable. Through quiet watching, counting, comparing, and recording, Mesopotamian scholars turned the moon's repeating motions into patterns of knowledge. Their work did not remain only in Mesopotamia. Over time, astronomical ideas and records traveled. Later Greek astronomers learned from Babylonian methods. Centuries afterward, scholars in the Islamic world preserved, studied, corrected, and expanded both Greek and earlier traditions. European astronomy, too, inherited part of this long chain. The moon seen over the Tigris and Euphrates became part of a much larger human conversation. And yet beneath all the tablets, calculations, and temple rituals, there remained the simple act of looking up. A scribe might pause with a reed stylus in hand. A farmer might stand beside an irrigation canal. A traveler might follow a pale road beyond the city wall. Above them, the moon moved at its own steady pace, not hurried, not still, waxing and waning across the month. The clay tablets have hardened. Many cities have become ruins. The rivers continue their long passage through the land. And in imagination, the crescent still rises over the flat horizon, slender and calm, just as it did for those ancient watchers. From these moonlit plains, the story drifts westward, toward another great river, where silver light rests upon the Nile, and temple columns glow softly after the heat of day. Chapter 4. The Moon Along the Nile. In the cool hours after sunset, when the heat of the day had softened and the river moved quietly between its banks, the moon could lay a silver path across the Nile. Its light touched reed beds and mud brick houses, temple walls and pale limestone, boats drawn up along the shore, and fields that waited in the dark. The great river, so central to ancient Egyptian life, reflected the sky above it in wavering lines. Stars appeared one by one. The moon rose gently, not alone, but as part of a wide and ordered heavens. For the people of ancient Egypt, the sky was full of meaning. The sun crossed the day, the stars marked the deep night. The annual rising of Sirius, a bright star, was connected with the season of the Nile flood, when waters renewed the land and left fertile silt behind. The moon, too, had its place in this celestial order. It changed shape, disappeared, returned, and grew bright again. Its rhythm suggested renewal, measurement, and cyclical return. Ancient Egypt lasted for thousands of years, and its beliefs were not the same in every period or every town. Religious ideas shifted, blended, and gathered new meanings over time. So when we speak of the Egyptian moon, we are not speaking of one single, simple idea. We are looking instead at a long river of images and practices, changing slowly like light on water. Egyptian timekeeping was also layered. The most famous Egyptian calendar was a civil calendar of 365 days. It was largely solar, meaning it followed the year of the sun, rather than the months of the moon. This calendar helped organize administration, work, offerings, and daily life. Yet lunar calendars also existed in Egyptian religious and temple life. A lunar calendar is based on the moon's phases, the changing shape of its bright part as seen from Earth. The moon's cycle from one new moon to the next is about 29.5 days, and this steady pattern was useful for marking sacred times. In temples, where ritual order mattered deeply, lunar phases could help structure festivals and ceremonies. The moon's changing form made it a natural symbol of restoration. It thinned, vanished from sight, and then returned as a young crescent in the evening sky. Night after night the crescent widened. The half-lit moon became rounder. The full moon shone like a pale disk over desert cliffs and river water. Then it began to wane again, gradually narrowing until the cycle began anew. To human eyes, this was a quiet lesson in return. One Egyptian deity closely linked with the moon was Khonsu. He was associated with travel, protection, and the passage of time. In art, Khonsu could be shown with a lunar disk and crescent above his head. He was sometimes connected with healing, restoration, and the journeying quality of the moon as it moved across the night sky. One might imagine a temple courtyard after dusk, its stones still holding a little warmth from the sunlit day. Columns cast long, soft shadows. Above them, the moon climbed slowly, its light resting on carved walls and polished surfaces. In such a setting, Khonsu's lunar nature would have felt close, calm, watchful, and regular. Another important figure with lunar associations was Thoth, god of wisdom, writing, calculation, and measured order. Thoth belonged to the world of scribes, records, numbers, and sacred knowledge. Because the moon measured time through its phases, it was natural for lunar symbolism to touch the domain of Thoth. In Egyptian thought, measuring was not merely practical, it was part of keeping the world in balance. To count days, to observe the sky, to perform rituals at the proper time, these acts belonged to a larger sense of order. The moon, with its visible cycle, offered a soft but reliable pattern. It was a light in the night, and a marker in the flow of days. Still, the moon was only one part of Egyptian sky watching. The sun held enormous importance. The stars formed sacred patterns. Sirius, rising before dawn at a certain season, became linked with the coming of the Nile's flood. This flood was not predicted by the moon, but by the broader seasonal rhythm of the year, especially through solar and stellar observation. The Egyptian sky was a great calendar written in many kinds of light. Along the river, people lived close to these rhythms. The Nile rose and fell. Fields were watered, planted, and harvested. Boats moved under sun and stars. In villages and cities, in temples and workshops, time passed through cycles of brightness and darkness, labor and festival, absence and return. The moon gave one of the gentlest images of that return. Its waxing and waning could be associated with healing and restoration, with the idea that what diminishes may be renewed. A thin crescent after darkness could feel like a beginning. A full moon over the Nile could feel like completion. Then the slow lessening of the light did not need to be an ending because the pattern was known. The moon would come back. White limestone glowed beneath the night sky. Reeds moved softly at the riverbank. The dark water carried reflections of stars, clouds, and the pale round moon. In temple spaces, in records and rituals, and in stories of gods such as Khonsu and Thoth, the moon helped ancient Egyptians think about time not as a straight line only, but as a sequence of returns. And as the Nile carried its silver reflection northward, the moon continued across the world. Far beyond the river valley, other people watched the same changing light. In another ancient land, careful observers would time months to the moon and seasons to the turning year. The silver path on water would become a reflection in garden ponds. Temple courtyards would give way to tiled rooftops, lantern glow, autumn gatherings, and the bright round moon of China. Chapter 5. The Moon in Ancient China. A round autumn moon rises softly above tiled rooftops, its light resting on curved eaves, garden stones, and the still surface of a pond. In the cool night air, lanterns glow with a gentle amber warmth. A small table is set in a courtyard. Tea steam curls upward, pale and quiet, and the moon's reflection trembles slightly in a bowl of water. Across the long history of China, the moon has been both a measure and a companion. It has helped organize time, guide festivals, inspire poems, and shape stories told from one generation to another. Like many ancient peoples, Chinese skywatchers noticed that the moon changed in a steady rhythm. It disappeared near the sun, returned as a fine crescent, grew night by night, became full and bright, and then slowly waned again. Traditional Chinese calendars are lunisolar. This means they follow both the moon and the sun. The months are tied to the moon, often beginning near the new moon, when the moon is close to the sun in the sky and usually cannot be seen. But the year must also stay connected to the seasons, to spring planting, summer heat, autumn harvest, and winter cold. Because 12 lunar months are shorter than a solar year, an extra month is sometimes added. This is called an intercalary month, a carefully placed additional month that helps the calendar remain in step with the turning year. In this way, the calendar became a quiet weaving of two rhythms. The moon gave the months their shape. The sun kept the year aligned with the seasons. Together, they helped people know when to hold ceremonies, when to observe festivals, when to mark beginnings, and when to look for the return of certain seasonal signs. Chinese astronomers were careful and patient observers. Over many centuries, they recorded eclipses, comets, novae, and the movements of planets. These records were written down by court astronomers and scholars, and many became part of long historical traditions. Some early eclipse records appear in ancient Chinese sources, though matching them exactly with modern calculations can be difficult. Dates, descriptions, and calendar systems changed over time, so scholars study them with care. An eclipse is an event of shadow and alignment. In a lunar eclipse, Earth's shadow falls across the moon. In a solar eclipse, the moon passes between Earth and the sun. Ancient observers did not always explain these events in the same way modern astronomy does, but they watched them closely. Their records became part of a long memory of the sky. The night sky in Chinese astronomy was organized in several ways. One important system was the 28 lunar mansions. These were divisions along the path the moon appears to travel among the stars. A lunar mansion is like a resting place or marker in the sky, a section through which the moon passes on its monthly journey. By noticing where the moon was among these star groups, astronomers could follow its motion and connect sky patterns with calendar time. One may imagine a scholar standing in a quiet courtyard, looking upward with practiced attention. The moon is not only a beautiful light, but also a moving body whose position can be noted, compared, and remembered. Beside the scholar, perhaps, a manuscript rests on a low table. Ink dries slowly on the page. A brush has written down the date, the weather, the moon's appearance and the place it held among the stars. Yet the moon in China was never only a subject for calculation. It also belonged to family, poetry, and festival life. The Mid-Autumn Festival, one of the best-known lunar celebrations, is centered on the bright autumn moon. It is associated with harvest, reunion, moon viewing, and the sharing of mooncakes. The festival as it is known today developed over time, changing through dynasties and regions, but its heart remains gentle and clear. People gather beneath a full moon and think of togetherness. Mooncakes, round and carefully made, echo the shape of the full moon. Their roundness can suggest completeness and reunion. Families may sit outside, pour tea, light lanterns, and look upward. The moon seems close enough to belong to the courtyard, yet far enough to belong to everyone. Its light falls on distant villages, river towns, palace roofs, mountain paths, and quiet gardens all at once. The moon also shines through Chinese mythology. One of the most beloved lunar figures is Chang'e, the moon goddess. Her story has many versions, told and retold across centuries. In some traditions, she drinks an elixir connected with immortality and rises to the moon, where she lives apart from the human world. The details differ from telling to telling, but the image endures. Chang'e in the pale lunar realm, graceful and distant, associated with beauty, longing, and the shining mid-autumn moon. Another important lunar figure is the moon rabbit, often called the jade rabbit in East Asian tradition. In many stories, the rabbit lives on the moon and is seen preparing a special medicine. When people look at the markings on the full moon, some imagine the shape of this rabbit in the light and shadow of its face. Other cultures have seen different figures there: a face, a woman, a tree, a man carrying a bundle. The moon's surface invites imagination because it is both familiar and mysterious, always visible, yet always out of reach. These stories do not replace astronomy, they rest beside it. In one part of life, the moon is measured in calendars and watched through careful records. In another, it is honored in poetry and festival, imagined as a palace, a companion, or a distant home. Human beings often hold both kinds of knowing at once, the knowledge of pattern and the knowledge of meaning. A poet might gaze at the moon and think of someone far away seeing the same light. A farmer might note the month and season. A scholar might compare the moon's place among the 28 lunar mansions. A family might share mooncakes under lantern light. All are part of the moon's history. The same round moon that rose above ancient courtyards also rose above roads, canals, fields, and watchtowers. It shone on bamboo leaves and river mist. It slipped between passing clouds and returned with calm regularity. Its phases gave structure to time, while its beauty softened the hours after sunset. And as that moonlit courtyard widens in the imagination, the view opens beyond one land and one tradition. The moon continues westward across the sky, over mountains and deserts, over temple lamps and lotus ponds, over scholars tracing numbers by lamplight, and poets listening to the quiet night. Its path leads onward into India's lunar mansions, into stories of Chandra and Soma, and into the many ancient worlds that watch the same silver light. Chapter 6: The Moon in India and the Wider Ancient World. The moon rises softly over a worn stone courtyard. The day's heat has faded from the walls, and the air has grown gentle. A few lamps glow near a temple doorway. Somewhere nearby, water rests in a lotus pond, holding a pale reflection of the sky. Above it all, the moon appears, quiet and familiar, its silver light touching roofs, trees, steps, and open hands. In India, as in many parts of the ancient world, the moon was not only something to admire. It was also a way of measuring time, a guide for festivals, a subject for careful calculation, and a presence in poetry and sacred story. Yet there was never just one Indian calendar or one single way of understanding the moon. Across regions, languages, communities, and centuries, many systems developed, each with its own rhythm. Some were lunar, following the moon's phases closely. Others were lunisolar, meaning they used moon-based months while also adjusting to the solar year, the year measured by the sun and the seasons. This helped keep months and festivals from drifting too far away from the seasons to which they were connected. In many traditional Indian calendars, time was shaped not simply by counting ordinary days, but by observing the relationship between the sun and the moon. One important word is tithi. A tithi is often translated as a lunar day, but it is not exactly the same as a sunrise to sunrise day. It is based on the changing angle between the sun and the moon as seen from Earth. As the moon moves along its path, that angle grows and changes, and each portion marks a tithi. Another important word is nakshatra. A nakshatra is a lunar mansion or a star division along the moon's path through the sky. Imagine the moon traveling night after night across a broad celestial road. The nakshatras are like gentle markers along that road, associated with particular stars or regions of the sky. By noticing where the moon appeared among these starry divisions, sky watchers could organize time, ritual, and astronomical knowledge. These ideas were part of a long tradition in which observation, mathematics, religion, and daily life often overlapped. The moon was measured carefully, but it was also cherished symbolically. It belonged to calendars and calculations, and also to psalms, stories, and images of beauty. In Indian religious and poetic traditions, the moon is associated with Chandra and Soma, names with deep and layered meanings. Chandra is often understood as a lunar deity, radiant and cool, moving through the night sky. Soma has connections to the moon, to sacred offering, and to older traditions whose meanings changed and unfolded over time. These names appear in different ways across texts and regions, carrying associations of brightness, nourishment, calmness, and cyclical return. The moon's changing shape made it especially meaningful for festivals. Many Hindu, Buddhist, and Jain observances are timed according to lunar or lunisolar calendars, though the exact systems differ across regions. Some festivals are linked to the full moon, when the night is bright and the lunar disk appears complete. Others are tied to the new moon, when the moon is near the sun in the sky and usually hidden from view. Still others follow particular tithis, giving the calendar a subtle, flowing pattern. Under such a calendar, time can feel like a series of returning forms. The dark moon gives way to a thin crescent. The crescent grows into a half-lit disk. The half-lit disk swells toward fullness. Then the full moon begins to wane, becoming smaller night by night, until it disappears again into darkness. This cycle repeats with quiet steadiness about every month, reminding people that time is not only a line moving forward, but also a circle returning. Indian astronomers studied these cycles with great care. They worked with numbers, geometry, and observation, developing mathematical astronomy over many centuries. One of the most important figures was Aryabhata, who wrote in the late 5th and early 6th century CE. Aryabhata offered natural explanations for eclipses, describing them in terms of shadows rather than as purely supernatural events. An eclipse happens when one celestial body blocks light or passes into shadow. In a lunar eclipse, Earth's shadow falls across the moon. In a solar eclipse, the moon passes between Earth and the sun. Aryabhata's explanations were part of a broader tradition of trying to understand the sky through pattern and reason. His work did not stand alone, but belonged to a long conversation among observers, calculators, and teachers. One may imagine a scholar seated by lamplight, tracing numbers onto a writing surface, looking up from time to time at the moon outside. The calculation and the vision belong together. The pale disk in the sky is both distant and immediate, both a heavenly body and a familiar companion. The moon also shone through Sanskrit poetry. Poets often described it as cool, soothing, and luminous. Its light might fall on a lover waiting in the night, on a palace balcony, on a forest path, or on the surface of still water. It could symbolize beauty, longing, tenderness, and calm. In warm climates, moonlight was sometimes imagined as cooling, a relief after the heat of day. The moon was not only bright, it was gentle. From India, the mind can wander outward, following the same moon as it rises over other lands. Far away in the forests and cities of Mesoamerica, Maya astronomers observed the sky with remarkable care. They recorded lunar cycles and included lunar tables in their astronomical traditions. Their work was part of a wider system of calendar making, ritual timing, and observation. Across islands of the Pacific, the moon could be important for navigation, fishing, tides, and seasonal awareness. People who knew the sea watched the sky, the winds, the stars, and the changing light of the moon. On some nights, a bright moon silvered the water. On others, darkness made the stars clearer. Knowledge of the heavens was practical, inherited, and carefully taught. In many indigenous traditions across the world, moon phases helped mark time for gatherings, ceremonies, hunting, harvesting, or storytelling. These traditions were and are highly diverse. Each community understood the moon through its own land, language, and memory. Some named the full moons according to seasonal signs. Some told stories of beings or figures seen in the moon's face. Some followed lunar rhythms alongside plant growth, animal movement, river changes, or weather. In parts of Africa, lunar observation also shaped calendars, rituals, and local knowledge. The first crescent after sunset could mark the beginning of a month. The full moon might offer light for travel or communal activity. In desert regions, forests, grasslands, and river valleys, the moon appeared within different ways of life, yet its steady phases remained visible to all who watched. Around the Mediterranean and the Near East, Persian, Greek, Roman, and other cultures gave the moon names, stories, and calendar roles. Some traditions honored lunar deities. Some used moon months for religious observances. Some joined lunar timing with solar seasons, adjusting the calendar so that important dates stayed close to their proper time of year. The details varied, but the pattern was familiar. People looked upward, noticed repetition, and made meaning from it. The wider ancient world was not a single chorus singing the same song. It was more like many quiet songs carried under the same sky. In one place, the moon guided a ritual date. In another, it helped a traveler measure the night. Elsewhere, it entered a poem, a myth, a calculation, or a painted image. It rose over deserts, forests, islands, mountains, courtyards, fields, and seas. And everywhere, it changed shape slowly enough to be followed by patient eyes. The moon invited both wonder and careful thought. It could be a deity, a symbol, a calendar marker, a poetic image, and an astronomical body, all at once. These meanings did not cancel one another. For many ancient people, the world was woven together. Number and story, sky and season, beauty and measurement. As the chapter of history turns toward the Greek world, the moon remains overhead, serene and bright. There, philosophers and astronomers would look at its phases, its eclipses, and its rounded form, and ask with geometry and observation how it shone, what shape it had, and what its quiet light might reveal about Earth and the heavens. Chapter 7. Greek Thinkers and the Shape of the Moon. A pale moon rises over the Aegean Sea, lifting slowly above the dark water. Along the shore, the evening air cools the marble steps and the worn stones of small harbors. Olive trees stand quietly on the hillsides, and the surface of the sea holds a path of silver light, broken only by the gentlest movement of waves. In such a place, beneath a clear sky, a thinker might draw a circle in sand, or mark a curve on a wax tablet, and look upward. The moon was still the familiar companion it had always been, the same changing light watched by farmers, sailors, poets, priests, and children. Yet in the Greek-speaking world of the ancient Mediterranean, many philosophers and astronomers began asking careful questions about what the moon was, how it moved, why it changed shape, and how far away it might be. They were not the first people to study the moon with care. Long before them, observers in Mesopotamia had recorded lunar phases, eclipses, and cycles on clay tablets. Other cultures had also watched the sky with patience and skill. Greek astronomy grew within this wider exchange of knowledge. It received ideas, observations, and numerical patterns from earlier traditions, especially from Babylonian astronomy. But Greek thinkers added their own habits of reasoning, geometry, philosophy, and the search for natural explanations. One of the important questions was simple to ask and beautiful to consider. Why does the moon shine? The moon does not make its own light, as a flame or the sun does. It shines by reflecting sunlight. Sunlight falls upon the moon, and the bright portion we see is the part turned toward both the sun and earth. As the moon moves around Earth, its sunlit half is seen from different angles. These changing appearances are called phases. A thin crescent is only a small part of the sunlit side visible to us. A half moon shows a wider angle. At full moon, the near side of the moon appears completely lit. Anaxagoras, a Greek thinker of the 5th century BCE, is often credited with explaining that the moon shines by reflected sunlight. He also gave natural explanations for eclipses. An eclipse is an event involving shadow or alignment. In a lunar eclipse, Earth comes between the sun and the moon, and Earth's shadow falls across the lunar surface. In a solar eclipse, the moon passes between Earth and the sun and blocks the sun's light from part of Earth. These are quiet ideas when spoken slowly, though they were powerful in their time. They turned attention away from mystery alone and toward the patient geometry of light and shadow. Imagine a lamp, a small ball and a wall. Move them gently, and the shadow changes. Ancient thinkers did not have modern instruments, but they had eyes, reason, and the night sky. They could watch the moon darken during a lunar eclipse and think about the shape of the shadow crossing it. Writing, in the 4th century BCE, used lunar eclipses in another important way. He argued that Earth is round because Earth's shadow on the moon is always curved. During a lunar eclipse, the edge of the shadow looks like part of a circle. Aristotle reasoned that only a spherical Earth would cast a consistently round shadow from many different directions. He also argued for spherical heavenly bodies, including the moon. To Aristotle and many who followed him, the cosmos was ordered and layered, with Earth near the center and the heavens moving around it. His view was not modern astronomy, but it was thoughtful, organized, and deeply influential. It gave later scholars a framework to discuss the moon's shape, motion, and place in the universe. Other Greek astronomers went further into measurement. Aristarchus of Samos, who lived in the 3rd century BCE, tried to estimate the relative sizes and distances of the sun and moon. His methods used geometry, especially the angles between Earth, moon, and sun. His numbers were not the same as modern measurements, because the angles were extremely difficult to measure accurately with the tools of his time. Yet the effort itself was remarkable. He treated the sky as something that could be measured, not only admired. One may picture Aristarchus watching the half-moon when the moon appears divided between light and dark. At that moment he understood that the angle between the sun and moon held a clue. The triangle formed by Earth, moon, and sun could in principle reveal distances. The heavens became a quiet diagram, vast and delicate, written not in ink but in light. Hipparchus, working in the 2nd century BCE, refined lunar theory with careful observations and geometry. He made improved estimates of the moon's distance and studied the moon's motion. The moon does not move across the sky with perfect simplicity. Its path has variations, and its apparent speed changes. To describe this, astronomers needed both observation and mathematical models. A model in this sense is a careful way of representing motion. It is like drawing circles and points to show how a body appears to move through the sky. A good model helps predict where the moon will be, when it will rise, and when an eclipse may occur. Hipparchus worked in this spirit, building on observations from earlier centuries and adding his own. Later, in the 2nd century CE, Claudius Ptolemy gathered and organized much of ancient astronomy in a great work known as the Almagest. Ptolemy's universe placed Earth at the center. This is called a geocentric model. Geo means Earth, and centric means centered. In Ptolemy's system, the moon, sun, planets, and stars moved around Earth in complex combinations of circles. Today we know that Earth and the moon both move around the sun, and that Ptolemy's model does not describe the solar system as modern science does. But for many centuries, his mathematical system was useful for predicting positions in the sky. It influenced astronomers across the Mediterranean world, the Islamic world, and medieval Europe. Within its pages, the moon became part of a carefully ordered mathematical cosmos. Greek lunar thought, then, was not a single discovery or a straight path. It was a long conversation. Some thinkers asked what the moon was made of. Some asked why it changed shape. Some studied eclipses. Some measured angles and distances. Some inherited Babylonian records and turned them into geometric patterns. Some looked at the moon as a physical body. Others saw it within a philosophical structure of the heavens. The moon continued to rise. It rose above islands and city walls, above ships resting in harbors, above classrooms, temples, and quiet courtyards. Its phases moved on as they always had, crescent, half, full, and back again. The same light that touched the sea also touched the diagrams of scholars. The same shadow that crossed the moon during an eclipse invited both wonder and thought. By drawing circles, by watching shadows, and by comparing angles, Greek philosophers and astronomers helped shape a new way of speaking about the moon. They showed that beauty and measurement could sit side by side. A moonlit night could inspire poetry, and it could also invite geometry. In time, these ideas did not remain in one place. Texts were copied, tables were studied, questions traveled from language to language, and from city to city. The geometry of the Greeks, joined with older observations and later refinements, moved onward through centuries. And so the story of the moon passes gently from the marble steps and open skies of the ancient Mediterranean to libraries filled with manuscripts, to brass instruments catching lamplight, and to scholars of the Islamic Golden Age watching the crescent moon from quiet courtyards beneath another clear night sky. Chapter 8: The Moon in the Islamic Golden Age. In a quiet courtyard, after sunset, the first thin crescent of the moon rests low in the western sky. Its light is delicate, like a curved thread of silver. Around the courtyard, stone walls still hold a little warmth from the day, while the evening air grows cool and clear. A lamp burns beside an open manuscript. Ink dries slowly on the page. Nearby, a brass instrument catches the lamplight and holds it softly, as if it too were reflecting a smaller moon. From roughly the 8th to the 14th centuries, across many regions of the Islamic world, scholars looked carefully at the heavens. This long period is often called the Islamic Golden Age, though it was not one single place or one single moment. It stretched across centuries, languages, cities, libraries, observatories, and courts of learning. In places such as Baghdad, Moraga, and later Samarkand, astronomers, mathematicians, translators, instrument makers, and scribes worked with great patience. They inherited knowledge from many earlier traditions. Greek astronomy, Persian star lore, Indian mathematics, and older observations from Mesopotamia all entered into their studies. But these scholars did far more than preserve what came before. They translated, questioned, corrected, measured, recalculated, and expanded. A text might be copied, then compared with the sky. A table might be improved after long observation. A model might be adjusted because the moon, night after night, did not quite match the old numbers. Astronomy mattered in daily and religious life. It helped with calendars, with the times of prayer, with determining direction, and with observing the beginning of lunar months. The Islamic calendar is lunar, meaning that its months follow the cycle of the moon rather than the cycle of the seasons. A lunar month begins with the new crescent, the first slim light seen after the dark of the new moon. In some communities, the month began by actual sighting of that crescent. In others, calculation also played an important role. Across time and place, practice varied, but the moon remained central. A lunar calendar has its own quiet rhythm. 12 lunar months make a year of about 354 days, shorter than the solar year by about 11 days. Because of this, Islamic months move gradually through the seasons. A month that falls in summer in one generation may in later years arrive in spring, winter, or autumn. The moon keeps its own count, returning from new moon to new moon in about 29.5 days. This interval is called the synodic month, the time it takes for the moon to return to the same phase as seen from Earth. For astronomers, this repeating rhythm invited careful study. The moon moves quickly against the background stars, and its path is not perfectly simple. Its apparent speed changes. Its position shifts. Eclipses occur only when the geometry of sun, earth, and moon comes into a special alignment. An eclipse, simply put, is an event involving shadow or blocked light. In a lunar eclipse, Earth's shadow falls across the moon. In a solar eclipse, the moon passes between Earth and the sun. To predict such events, scholars needed numbers, angles, and patient observation. One of the important tools of this work was the Zij, an astronomical table. A Zij might include numbers for the positions of the sun, moon, planets, and stars. It could help an astronomer calculate when a celestial body would rise, set, or reach a certain place in the sky. These tables were not merely lists. They were the result of observation, mathematics, correction, and tradition. Turning the pages of a Zij, one can imagine rows of numbers arranged with care, like a quiet map of time. Among the scholars who refined these calculations was al-Batini, who lived in the 9th and early 10th centuries. He made careful observations and refined solar and lunar calculations. He stands as one example of how observation and mathematics work together. The eye at the instrument, the hand at the page, the mind comparing the heavens with the table. Another wide-ranging scholar was al-Biruni. He wrote about astronomy, geography, calendars, and measurement. He compared different systems of timekeeping and showed deep interest in how cultures measured the sky and the earth. His work reminds us that the moon was not only an object above the world, it was part of how people organized human life below it. A calendar is both celestial and social. It belongs to the sky, but also to markets, festivals, journeys, records, and memory. Then there was Ibn al-Haytham, known especially for his work on optics, the study of light and vision. Optics asks how light travels, how the eye sees, and how images are formed. His careful thinking about light influenced many later scholars. Although he is most famous for his work on light and vision, he also engaged with astronomical questions. In a world where the moon shines by reflected sunlight, the study of light naturally touched the study of the heavens. Later, Ibn al-Shatir developed mathematical models that improved on aspects of the older Ptolemaic system. Ptolemy, the influential Greek astronomer, had described the heavens using a geocentric model, placing Earth at the center. His system was mathematically powerful, but it also left questions. Islamic astronomers studied it closely and did not simply accept it unchanged. Ibn al-Shatir and others adjusted the geometry, seeking models that better matched observation and mathematical elegance. Their work became part of the long, unfolding conversation that later influenced astronomy in Europe as well. The instruments of these scholars were beautiful as well as useful. The astrolabe was one of the most versatile. Often made of brass, it could help determine time, locate stars, and solve problems of celestial position. It was a kind of portable map of the sky, held in the hand. A quadrant, shaped like a quarter circle, was used to measure angles above the horizon. An armillary sphere used rings to represent the great circles of the heavens. Large mural instruments, fixed to walls, allowed observers to measure positions with greater steadiness. Imagine such an instrument under a clear night sky. The moon rises slowly above a dark roofline. A scholar waits for it to cross a marked line. Another notes the time. A scribe records the number. The work is quiet, repeated, and exacting. Many nights may pass with small adjustments. Clouds may interfere. Dust may settle on the brass. A calculation may be corrected, and then corrected again. Knowledge grows not in a sudden blaze, but like the waxing moon itself, by degrees. In Baghdad, scholarly circles helped foster translation and study. In Moraga, a major observatory became a place where astronomers developed sophisticated models and tables. Later, in Samarkand, astronomical observation continued with remarkable instruments and careful star catalogs. These centers show how knowledge moved across generations, like moonlight across courtyards. The moon was part of all this work, a marker of months, a subject of calculation, a companion to religious and civic time, and a body whose motion tested the skill of astronomers. Its crescent marked beginnings, its fullness illuminated nights, its eclipses invited geometry, its path through the sky connected mathematics with lived experience. And so, in the soft lamplight of a library, the moon passed from observation into ink. It entered tables, diagrams, commentaries, and instruments. It was measured in degrees, watched from terraces, discussed in books, and sought at the horizon as a new month began. The scholars of the Islamic world received an ancient conversation and gave it new depth, new precision, and new forms. As the pages of astronomical tables turn softly, another kind of page begins to appear, the calendar page of medieval Europe, with feast days, saints' days, farming seasons, and painted moons in the margins. The brass astrolabe gives way gently to candlelit manuscripts and quiet fields. Above them all, the same moon continues its slow path, silver and steady in the night. Chapter 9. Medieval Europe and the Moonlit Imagination. A full moon rises over a quiet medieval field, silvering the hedgerows and laying a pale path along a narrow lane. The day's work has softened into evening. Smoke thins above cottage roofs. Somewhere beyond the fields, a church bell marks the hour, its sound moving slowly through the cool air. In the distance, the windows of a cathedral hold the last blue of twilight, while above them the moon keeps its calm place among the clouds. In medieval Europe, the moon was both familiar and full of meaning. It belonged to the sky, but also to the page, the field, the church, and the household. People watched it because it gave light. They watched it because it changed. They watched it because its changing helped organize time. Calendars of the medieval world were often rich and layered. A single calendar might mark the phases of the moon, the feast days of saints, the seasons of farming, and the great celebrations of the church year. In manuscripts, these calendars could be practical and beautiful at once. A month might be shown with a farmer pruning vines, sowing seed, cutting hay, or gathering grapes. Nearby, small symbols might show the moon's age or phase, along with lists of holy days written in careful script. The moon was especially important in the calculation of Easter, the central feast of the Christian year. Easter was not fixed to the same date every year. Instead, it was linked to the first Sunday after the ecclesiastical full moon, following the spring equinox, according to church calendar rules. The word ecclesiastical here means belonging to the church's system of reckoning. This church full moon was an approximation used for calendar purposes. It did not always match the exact astronomical full moon seen in the sky. The method for making these calculations was called computus. The word simply means computation or calculation. Computus brought together knowledge of the solar year, lunar cycles, weekdays, and church tradition. Monks and scholars copied tables, compared cycles, and worked out future dates with patient care. To modernize, the rules can seem intricate, but their purpose was steady and practical, to keep the rhythm of worship in order from year to year. One can imagine a monastic room in winter, quiet except for the faint scrape of a pen. A candle burns beside an open manuscript. The page is ruled with lines. Numbers and letters form columns. A scholar bends over the work, not hurried, but attentive. Outside, the moon may be hidden behind cloud, yet its pattern is present in the table, held in ink. The moon also shone through medieval art. It appeared in illuminated manuscripts, where painted colors and gold leaf caught the light like small pieces of dawn. In psalters, books of hours, and agricultural calendars, the moon might be drawn as a silver disk, a crescent, or a face looking out from a painted sky. Books of hours were prayer books used by lay people, often beautifully decorated. They guided daily devotion through prayers assigned to different times. Sometimes the moon appeared with the sun as part of a larger sacred image, two lights set in balance. In later medieval and Renaissance Christian art, a crescent moon was sometimes shown beneath the feet of the Virgin Mary. This image drew from religious symbolism and scripture, and it became especially familiar in certain devotional traditions. The crescent was not only an astronomical shape, it became a sign within a visual language of heaven and reflected light. Beyond churches and manuscripts, the moon belonged to the countryside. Medieval rural life was shaped by natural light in ways that are easy to forget in a brightly lit age. A clear night near the full moon could make a road more visible. It could help travelers find their way across fields or between villages. It could allow certain kinds of work or gathering to continue after sunset. Moonlight did not turn night into day, but it softened the darkness and gave the world edges. A gate, a bridge, a line of trees, the pale surface of a stream. Medieval people also connected the moon with tides, fertility, medicine, and astrology. These beliefs varied by region, education, and tradition. In medicine and natural philosophy, the moon was often imagined to influence the human body. Medieval medical thought drew heavily on ancient Greek and Roman ideas, including the theory of humors, which imagined health as a balance of bodily fluids. Because the moon visibly waxed and waned, many people associated it with growth, moisture, fertility, and change. Some physicians and astrologers chose times for treatments according to lunar phases or the moon's position in the zodiac. These beliefs were part of the learned world of the time, but they should be understood as history rather than modern science. Today, many medieval medical and astrological claims are not supported by scientific evidence. Still, they show how carefully people tried to place human life within the larger order of nature. The moon, changing night by night, seemed to offer a pattern that could be read. Astrology and astronomy were closely connected in medieval thought. Astronomy studied the motions of celestial bodies. Astrology interpreted those motions as meaningful for earthly affairs. The two were not separated as clearly as they are today. A scholar might calculate the moon's position with mathematical care, and also believe that its position carried significance. In this way, the moon was both measured and imagined. Folklore gave the moon another kind of life. Many medieval people knew stories of the man in the moon, a figure seen in the mottled markings of the lunar face. Different tales explained who he was and why he was there. Some said he carried thorns or wood, some made him a moral example, others simply treated him as a familiar presence in the night sky. The dark patches on the moon, which we now know are broad plains called maria, invited the eye to make shapes: a face, a figure, a burden on a shoulder. These were patterns made by human imagination from lunar shadow. And so the medieval moon was many things at once. It was a lamp over fields, it was a sign in a calendar, it was a guide for feast days, it was a symbol in sacred art, a subject for calculation, a companion to travelers, and a figure in stories told beside the fire. If we turn one more manuscript page, we might see the moon painted in pale silver above a small landscape of hills and towers. The gold leaf glimmers softly, the ink lines are steady. Yet beyond the painted page, the real moon is rising, its surface still unseen in detail by medieval eyes. Soon another kind of looking will begin. The moon of manuscripts and calendar tables will meet the moon seen through glass. In quiet rooms, with small telescopes pointed toward the night, observers will discover shadows, mountains, craters, and plains, an ancient companion becoming, little by little, a visible world. Chapter 10: Telescopes and a New Lunar Landscape. On a quiet evening in the early 17th century, the moon rose as it always had, pale and steady above rooftops, fields, towers, and narrow streets. To the eye alone, it was already familiar. A bright disk, sometimes full and round, sometimes cut into a silver crescent, sometimes half in light and half in darkness. For thousands of years, people had watched it with patience and care. They had counted its phases, marked its return, told stories beneath it, and used its gentle light to walk by. But now a new kind of instrument was being lifted toward the sky. The telescope was still young then. It was a simple tube with shaped glass at either end, able to make distant things appear closer. Early telescopes were not as clear or powerful as the ones astronomers use today. Their lenses could blur, bend colors, and show only a small patch of sky at a time. Yet even through such modest glass, the moon began to change in human understanding. It was no longer only a shining face in the heavens. It became a place with texture, with shadows, with highlands and hollows. In England, in 1609, Thomas Harriot turned a telescope toward the moon and made sketches of what he saw. His drawings were among the earliest known telescopic records of the lunar surface. Harriot did not publish them widely at the time, so they remained quiet, tucked into the history of observation like a candle kept in a private room. Still, they show that more than one careful observer was beginning to see the moon in a new way. That same year, in Italy, Galileo Galilei also studied the moon through a telescope. He watched night after night, paying close attention to the changing boundary between light and dark. In 1610, he published his observations in a small but important book called Sidereus Nuncius, or Starry Messenger. In it he described a moon that was not smooth and perfect, but uneven, with mountains, valleys, and shadowed places. The old idea, inherited in many forms from ancient philosophy, was that the heavens were made of perfect, unchanging bodies. Earth was the place of roughness and alteration, while the moon and planets were often imagined as smooth and noble spheres. Galileo's telescope did not erase older ideas all at once. People did not immediately agree about what the new observations meant. But the telescope offered a quiet, persistent kind of evidence. It showed that the moon had a landscape. One of the most useful places to look was the terminator. The terminator is the line between day and night on the moon, the place where sunlight ends and darkness begins. Near this line, the sun shines across the lunar surface at a low angle, much as it does on Earth, near sunrise or sunset. Low sunlight makes shadows long. A small hill casts a darker shape. A raised rim around a hollow catches the light, while the hollow itself remains dim. Through the telescope, these slow shadows revealed relief, which means height and depth. Galileo noticed bright points of light appearing beyond the dark side of the terminator, like mountaintops catching dawn before the land below them. He reasoned that these must be high places on the moon. He even tried to estimate their height by studying the length and position of their shadows. His numbers were not exact by modern standards, but the method was thoughtful. The moon was becoming something that could be measured. Imagine a small room in the late evening. A telescope rests near an open window, angled toward the quiet sky. A candle burns beside paper and ink. Outside, the moon's pale light touches stone walls and tiled roofs. Inside, an observer looks, pauses, and draws. The hand moves slowly across the page, marking dark patches, bright edges, and uneven borders. What appears at first to be a white disk becomes a world of gentle contrasts. The moon's surface is varied. It has mountains, broad plains, and craters. Craters are bowl-shaped hollows, most of them formed long ago by impacts from space rocks. The moon also has dark, smoother-looking regions called maria. The word maria is Latin for seas, because early observers thought these dark patches might be bodies of water. They are not seas in the earthly sense. They are ancient volcanic plains, made when lava flowed across low regions of the moon and later cooled into dark rock. To the eye, they still look like soft gray markings on the lunar face, the familiar shapes that many cultures have seen as figures, animals, or patterns. As telescopes improved, observers began to make more detailed maps. The moon invited careful looking. Its surface was near enough to show markings, yet distant enough to remain silent and unreachable. Each night, as the phase changed, different features stood out. A crater nearly invisible under high sunlight might appear clearly when the Terminator passed beside it. A mountain range could seem to rise out of darkness, its peaks touched by silver light. In 1647, Johannes Hevelius published a major work called Selenographia. The word means the study or mapping of the moon. Hevelius made careful lunar drawings and maps, giving names to features in his own system. His work was large, detailed, and beautifully made, part scientific record and part quiet tribute to the lunar landscape. A few years later, in 1651, Giovanni Battista Riccioli and Francesco Maria Grimaldi produced another influential lunar map. Grimaldi, the skilled observer, helped create the map's detailed appearance, while Riccioli developed a naming system that became especially lasting. Many lunar craters still carry names from Riccioli's system today, including the names of astronomers, philosophers, and mathematicians from many eras. In this way, the moon became not only a landscape of mountains and plains, but also a kind of memory map, holding the names of people who had studied the heavens. The naming was not always simple, and different systems competed for a time, yet gradually the moon's visible face became more familiar to scholars. Its brighter highlands and darker plains were charted, its craters were outlined, its curved shadows were compared from night to night. The once featureless disk had become a mapped world. Still, there was gentleness in the change. The telescope did not take away the moon's beauty. If anything, it added to it. The silver face seen by poets and farmers was the same moon seen by astronomers through glass. The difference was that now, within that pale light, observers could imagine ridges, basins, and quiet plains stretching beneath a black sky. They could see that the moon was not only a marker of time, nor only a symbol in stories, but a neighboring body with its own ancient surface. And so, as the 17th century moved onward, the moon rose over observatories, gardens, harbors, and sleeping towns, carrying both old meanings and new details. Its light still softened rivers and rooftops. Its phases still marked the passing month. But in notebooks and printed books, in careful engravings and maps, another moon was taking shape. A moon of craters, maria, mountains, and long shadows. From here, the story drifts forward into later centuries, when clearer telescopes, finer maps, and the first silver-gray photographs would bring the lunar landscape into sharper view. Measurement and imagination would travel together, and people would begin to wonder not only what the moon was like, but whether one day it might be reached. Chapter 11. Mapping, Measuring, and Dreaming of the Moon. In a quiet observatory, long after sunset, the moon could seem close enough to invite a careful hand. Its pale face rested in the telescope glass, bright and still, crossed by soft shadows and rounded plains. On a wooden desk nearby, papers lay open, weighted at the corners, covered with fine ink lines. Each line was an attempt to remember what the eye had seen: a crater rim, a mountain chain, a dark plain, a bright ray spreading outward like frost. After the first telescopic observations of the 17th century, the moon slowly became not only a light in the sky, but a landscape to be mapped. Earlier observers had seen its markings with the unaided eye, but telescopes gave those markings shape and depth. The line between lunar day and lunar night, called the terminator, revealed hills and hollows by the length of their shadows. When sunlight struck the moon from a low angle, mountains seemed to rise from darkness, and craters appeared as delicate rings. Over time, telescopes improved, lenses became clearer, mountings became steadier. Observers learned to wait for calm air, when the image did not tremble as much. They returned to the same regions again and again, comparing what they saw with earlier drawings. Lunar mapping, sometimes called selenography, became a patient art. Selenography simply means the study or mapping of the moon's surface, from selene, a Greek name for the moon. By the 19th century, some maps had become remarkably detailed. Two German observers, Wilhelm Beer and Johann Heinrich Madler, worked together in the 1830s to produce careful lunar maps and descriptions. Their work was admired for its precision. They drew craters, plains, mountains, and valleys with a steadiness that came from many hours of observation. The moon, once imagined as a smooth heavenly lamp, had become a known world of ridges and basins, though still distant and silent. The dark patches on the moon had long been called maria, a Latin word meaning seas. Early observers had imagined them as bodies of water, but as study improved, astronomers came to understand that these were not seas at all. They were broad, dark plains formed by ancient lava flows, long hardened into rock. By the 19th century, it was generally understood that the moon had no visible oceans, no rivers, and no substantial atmosphere like Earth's. That phrase, no substantial atmosphere, is important. Earth's atmosphere is thick enough to carry clouds, winds, weather, and the blue color of the daytime sky. The moon has nothing like that. It does have an extremely thin exosphere, a faint scattering of atoms and molecules around it, but it is far too slight to make weather or to soften the surface with air as Earth's atmosphere does. On the moon, shadows are sharp, the sky above the surface is black. Still, from Earth the moon kept offering new ways to be known. In the 19th century, photography began to join drawing and measurement. A photograph could hold the moon's face in silver-gray tones, preserving details that could be studied later. In 1840, John William Draper made an early successful daguerreotype of the moon. A daguerreotype was an early kind of photograph made on a polished metal plate. Its image was delicate, almost ghostly, but it marked an important step. The moon could now leave its own trace through light. These early photographs were not as crisp as modern images, but they carried a quiet wonder. The moon's familiar face appeared in a new form, not drawn by hand but received by chemistry and light. The pale disk that had shone over fields, temples, cities, and seas had entered the age of photography. Yet, even with the best telescopes and the first cameras, half the moon remained hidden. From Earth, we see nearly the same face of the moon all the time. This happens because of tidal locking. Tidal locking means that the moon rotates or turns at about the same rate that it orbits Earth. As it goes around us, it keeps nearly the same side turned toward us, like a dancer slowly circling while always facing a partner. Because of this, the far side of the moon could not be seen from Earth before spacecraft. It is sometimes called the dark side, but that name can be misleading. The far side is not permanently dark. It receives sunlight just as the near side does, as the moon moves through its phases. It is far because it faces away from Earth. For centuries it remained beyond human sight, a quiet blank in every map. As maps grew more detailed, another question rested beneath them. Where did the moon come from? Different ideas were proposed. One idea, called the fission theory, suggested that the moon had once split away from the young Earth. Another, the capture theory, imagined the moon forming elsewhere and later being caught by Earth's gravity. A third idea, co-formation, proposed that Earth and moon formed together from the same cloud of early material. In the 20th century, a leading explanation became known as the giant impact hypothesis. This idea suggests that, very early in solar system history, a large body roughly the size of Mars struck the young Earth, and debris from that event eventually gathered to form the moon. Evidence from lunar rocks brought back by Apollo astronauts later gave strong support to this model, though scientists still refine the details. The moon's beginning remains a subject of careful study, not a closed book, but the giant impact hypothesis is the strongest guide we have today. While scientists measured and mapped, writers dreamed. Long before machines could travel beyond Earth, stories carried human imagination toward the moon. Johannes Kepler wrote Somnium, a dreamlike tale of a journey to the moon, shaped by his astronomical knowledge. Francis Godwin wrote The Man in the Moon, imagining travel through the heavens in a very different way. Cyrano de Bergerac created lunar voyage writings, full of invention and philosophical reflection. Later, Jules Verne's From the Earth to the Moon gave readers a 19th-century vision of a voyage launched from Earth. These stories were not all scientific in the modern sense. Some were fanciful, some symbolic, some playful in their own time, but together they show how the moon had become more than a distant light. It had become a possible destination in the mind. People imagined crossing the dark space between worlds, looking back at Earth, and arriving on that silver-gray surface, already familiar from maps. Then, near the edge of the modern age, thinkers began to make the dream more technical. Konstantin Tsiolkovsky, a Russian schoolteacher and scientist, wrote about rocketry and space travel with remarkable seriousness. His work helped make spaceflight seem not only like a story, but like a problem that mathematics and engineering might one day solve. So the moon passed through many forms of knowing. It was drawn by eye, measured by telescope, fixed in early photographs, studied as a world without oceans or Earth-like air, and imagined as a place that travelers might someday reach. The maps on wooden desks became more detailed, the silver photographs became clearer, the stories became more practical. Slowly, gently, the imagined journey moved closer to becoming a real one. And above it all, the moon continued its old path across the sky. One side turned toward Earth, familiar and marked. The far side waited unseen. The quiet plains and craters held their places in sunlight and shadow. In the next chapter of human history, machines would cross the distance at last, and the hidden hemisphere would appear in photographs. Maps and dreams would give way to spacecraft, footprints, and the moon as a place touched by human hands. Chapter 12. Footprints, Spacecraft, and the Moon Tonight. In the middle of the 20th century, the moon, so long watched from fields, temples, observatories, rooftops, and shorelines, became something more than a distant light. It became a place that human-made machines could reach. For all the centuries before, people had known the moon by sight and calculation. They had followed its phases, named its dark plains, measured its path, and drawn its craters in careful ink. But the space age brought a new kind of closeness. Instruments crossed the quiet distance between Earth and Moon. Cameras looked down on gray plains. Small spacecraft drifted over ridges and basins that no human eye had seen from nearby before. In 1959, the Soviet spacecraft Luna 2 became the first human-made object to reach the moon. Its arrival marked a gentle turning point in history. The moon was no longer only observed from afar. A creation of Earth had touched it. That same year, Luna 3 gave humanity another remarkable gift. It sent back the first images of the moon's far side. This is sometimes called the dark side, but that phrase can be misleading. The far side is not always dark. It receives sunlight, just as the near side does. It is called the far side because it faces away from Earth. The moon keeps nearly the same face turned toward us because of tidal locking, meaning it rotates once in about the same time it takes to orbit Earth once. Before Luna 3, no one had seen that hidden half of the moon. For all of human history, it had been beyond direct view. Then, in grainy images, the far side appeared, cratered, ancient, and silent, another part of the same familiar companion. In the years that followed, other spacecraft helped prepare the way for crewed journeys. The Ranger mission sent close images before impact. Surveyor spacecraft made soft landings and studied the surface directly. Lunar orbiter missions circled the moon and photographed possible landing sites. Step by step, gently and carefully, the moon became better known as a landscape, not smooth silver, but dust, stone, slopes, shadows, and open plains. Then came Apollo 8 in 1968. 3 astronauts traveled around the moon, becoming the first people to orbit another world. From lunar orbit, they saw Earth rising above the moon's horizon, blue and white against black space. That image helped many people see Earth itself with new tenderness. A small, bright world, held in darkness, carrying oceans, clouds, forests, cities, deserts, and every human story. In 1969, Apollo 11 made the first crewed lunar landing. A spacecraft rested on the surface, and human footprints pressed into the fine lunar dust, called regolith. Regolith is the loose dust and broken rock that covers much of the moon. Because the moon has no wind and no rain, those footprints can remain for a very long time, though not forever. Space weathering and future activity can slowly disturb them. Apollo 11 was followed by other landings. In all, 6 Apollo missions reached the lunar surface. Apollo 11, 12, 14, 15, 16, and 17. Between 1969 and 1972, 12 astronauts walked on the moon. They moved across gray ground beneath a black sky, while Earth hung above them, bright and distant. They collected rocks, soil, and core samples, bringing back about 382 kilograms of lunar material. These samples changed lunar science deeply. In laboratories on Earth, scientists studied the minerals, ages, and textures of moon rocks. The samples helped show that many of the dark lunar plains, called maria, were formed by ancient lava flows. They also strengthened the leading idea for the moon's origin, the giant impact hypothesis. This theory suggests that the moon formed after a Mars-sized body struck the early Earth, sending material into orbit that eventually gathered into the moon. The broad idea is well supported, though scientists continue to refine the details. The Soviet Luna program also returned lunar samples robotically. These missions showed that machines, too, could gather pieces of another world and bring them home. Together, crude and robotic exploration helped turn the moon from a distant disk into a physical place with history written in stone. After Apollo, lunar exploration did not end. It changed form and widened across nations. Later missions studied the moon's topography, meaning the shapes of its mountains, basins, and plains. They measured gravity, mapped minerals, and searched for signs of water ice. Clementine, in the 1990s, mapped the moon in new wavelengths of light. Lunar Prospector studied its composition and gravity. Japan's Selene, also called Kaguya, returned detailed observations and graceful views of the lunar surface and Earth beyond it. India's Chandrayaan-1 helped confirm signatures of water and hydroxyl on the moon. Hydroxyl is a molecule made of hydrogen and oxygen, related to water but not the same as liquid water. The discovery did not mean there were lakes or rivers. Instead, it showed that water-related molecules existed in lunar materials, and that water ice may be present in especially cold places. One of the most important areas of interest is near the lunar poles. There, some craters contain permanently shadowed regions, places where sunlight has not reached for very long periods. In these deep cold traps, water ice is believed to exist. How much there is, where it lies, and how accessible it may be are still active questions. The answers matter for science, and perhaps for future explorers. The Lunar Reconnaissance Orbiter has mapped the moon in extraordinary detail, showing landing sites, slopes, temperatures, and shadows. China's Chang'e missions have orbited, landed, roved, and returned samples, expanding modern lunar knowledge. Other international missions continue to add to the picture, each one a quiet continuation of the old human habit of looking up and wondering. Some Apollo astronauts left special devices on the moon, called retroreflectors. A retroreflector is made to send light back toward its source. From Earth, scientists can aim laser beams at these reflectors and measure how long the light takes to return. In this way, they can measure the Earth-Moon distance with great precision. These measurements show that the moon is slowly moving away from Earth at about 3.8 centimeters per year. It is a very small change in a human lifetime, about the width of a few fingertips each year. Yet across immense spans of time, such small motions matter. The moon is steady to our eyes, but it is not completely still. It changes slowly through impacts, through space weathering, and through its gradual retreat from Earth. Modern lunar exploration continues, with special interest in the South Polar region, in geology, in resources, and in the possibility of future human missions. Scientists study the moon to know the moon itself more deeply, and to continue the long record of human curiosity that began with simple watching. And still, after spacecraft, samples, maps, and measurements, the moon remains what it has always been to human beings, a quiet presence above the turning Earth. It rises over modern cities where its light rests on glass towers and narrow streets. It rises over farms, silvering fields and fences. It rises over deserts, forests, islands, and dark water. It touches ancient ruins and present-day rooftops with the same pale glow. It appears between passing clouds, reflected in ponds, rivers, harbors, and rain-wet roads. To prehistoric watchers, it was a changing light in the night. To early calendar makers, it was a measure of months. To scribes, priests, poets, philosophers, astronomers, and telescope makers, it was a sign, a question, a world, and a mirror for thought. To astronauts and spacecraft, it became a destination. Yet tonight, it is once again simply the moon. Not only a clock, not only a symbol, not only a map, a memory, or a place where footprints rest in dust. It is the same companion that has traveled beside Earth through all of human history, rising softly above the horizon, carrying old stories in its light, and shining quietly over the world below.